And data structure. Internal sorting machine. Introduction. Sorting techniques can be classified into two types: internal sorting techniques and external sorting techniques. Any sorting algorithm that uses main memory exclusive during the sorting is called as internal sorting algorithm. Internal sorting is faster than external sorting. Some examples: internal sorting algorithms are insertion sort, bubble sort, selection sort, heap sort, shell sort, bucket sort, quick sort, radix sort. Any sort algorithm that use external memory such as tape or disk during the sorting is called as external sorting algorithm. Merge sort is one of the external sort algorithm. These are the sorting themes. Classifications of sorts are classified into two types: internal and external. Internal and again classified into three types: insertion, selection, exchange. Insertion, there is insertion shell and insertion and shell sort. In selection there are selection sort and heap sort. Exchange, bubble and quick sorts are there. In external there is external is also known as merge sort. There are three types of external sorts: natural, balanced, polyphases. Insertion sort, the insertion sort is like the way we sort playing cards in our hand. We using insertion sort when the element number is small, which can be helpful while array input is sorted. Mostly only few elements are not in their place in a complete array. For sorting elements that are sorted in a reverse order, it take maximum times. It is highly efficient on some list. Worst case complexity of slot is 0 into n square. N square, when data is already sorted, that is the best case of insertion sort, and take 0 into n times n times. The below table showing the process of insertion sorting. The shaded element represents order published as the algorithm makes each pass. We started by supposing a list which has one item position 0 is already sorted one each step for each element 1 through n minus 1. Current item is compared with those in sublist which are already sorted. As we see in table, into the already sorted sublist, shifted those items which are greater to right items. Finally we reach smaller item in the end of the sublist. Current item can be inserted. Example for a insertion sort. Insertion sort, sorting below elements are in increasing order by using insertion sort. We can see that 5 2 1 3 6 4. Compare the first and second element 5 and 2, arranging in increasing order. uh, sorting will be done as increasing in order: 2 5 1 3 6. Next sort the first three elements in increasing order: 1 2 5 3 6 4. Next sort the first four elements in increasing order: 1 2 3 4, 1 2 3 5 6 4. Next sort the first five elements increasing order: 1 2 3 5 6 4. Next sort the first six elements in increasing order: 2 3 4 5 6. Bubble sort. If n elements are given in memory, then the sort we do following steps. First compare the first and second element of array. First less than second, and then compare the second with the third. If second is greater than third, the interchange the value of second and third. Now compare the value of third which has the value of second with the fourth. Similarly compare until the n minus 1 elements is compared with the nth element. Now the highest value element is reached at the nth place, and now elements will be compared until n minus 1 elements. Disadvantages of sorting. Bubble sort. It is acceptable for sorting a table which contains a small number of records, but it becomes difficult for large size table. This is the example for bubble sort. this is the example for bubble sort algorithms. Bubble sort into a list comma n into n, start. First we are going to right, first start, second set I is equal to 0, repeat step 4 5 and 8 while I is less than n minus 1, I is equal to I plus 1, repeat step 6 7 while I is less than n. If list I is less than list I, t temp is equal to list list I exchanges ai and list ai is equal to list ai is equal to temp, set I is equal to I plus 1, set I is equal to I plus 1 and stop. Selection sort, as the name suggests, selection is a selection of an element and keeping it in the sorted order. If we have a list of elements in unsorted order, we want to make a list of elements in sorted order, then first we will take the smallest element and keep in the new list, after the second smallest element, and so on until the largest element of list. Let us take an array a0 comma a1 comma so on a n minus 1 of elements. First we will search the position of the small elements from a0 to a n minus 1, then we will interchange that the smallest element with a0. Now we will search the position of smallest element, second smallest element, because a0 is the first smallest element from a1, so on a n minus 1, they interchange that the smallest element with a1. Similarly the process will be for a2, so on a n minus 1. Example for this sort, selection sort, finding the minimum element. If it is not the first element, then interchange the first element and minimum element, then the list become 11 23 74 42 65 58 78 36 99 87 pass 1. If the second minimum element, and if it is not second element, then the interchange second element and second minimum element, then the list becomes 11 23 74 74 42 65 58 94 36 99 87 pass 2, continually till passes 9, continually it repeats passing 9. An algorithm of selection sort, selection into a a of into n start, set I is equal to 0, repeat step 4 comma 5 and 7 while I is less than n minus 1, set minimum I and set I is equal to I plus 1, repeat the step 6 while I is less than n. If I is less than a minimum, set minimum is equal to 1, temp is equal to ai is equal to a minimum is equal to temp, stop. Quick sort, the basic version of quick sort algorithm was invented by CAR Hoare in 1960 and formally introduced quick sort in 1962. It is used on the principle of divide and conquer. Quick sort is an algorithm of choice in many situations because it is not difficult to implement. It is good general purpose sort and it consumes relatively fewer resources during execution. The idea behind this sort is that sorting is much easier in two sort list rather than one long list. Divide and conquer means divide the big problem into two small problems and then those two small problems into two small one, and so on. Example, we have a list of 100 names and we want to list them alphabetically, then we will make two lists for name a to L and M to Z from original list. Then we will divide list A to L into A to F and G to L and so on until the list could be easily sorted. Similarly, policy we will adopt for the list M to Z. Parallelly quick sort, it is conducted as a dependable algorithm that can be parallelized, which also considered a preferable processed sorting algorithm is the popularization of quick sort algorithm can be gained for elements in network processing in the simplest way. The main form of parallel quicksort algorithm is patrioting of the information. Heap sort. Heap sort is the most active algorithm in selection sorting, in which select the largest element in the list and put it at the beginning, or determine the smallest element in the list and sort it in the end of the list. And this process continues of the remaining element in an effective and quickly way until the list becomes sorted. It uses a particular data structure of executing sort operation, which called heap. Heap is a particular type of binary tree. This algorithm makes the heap from given data that is given to be sorted. Thank you.